Alright, welcome to this video. I hope you guys are doing good. So in this video, I'm going to talk about the Newton's method. What do you mean by Newton's method first? Newton's method is a method that depends on the derivative or equation of the tangent line, okay, that finds the solution of an equation, or you can say that finds the zero of a function. What do you mean by zero? Zero of a function is basically the root of an equation, or x-intercept, you can say, right? So basically you are trying to find out x-intercept of this function y equals to fx. But there is one condition that the function must satisfy to use the Newton's method. So the condition is the function fx must be continuous in the interval ab, okay? And this also must be differentiable. F of x is differentiable on the interval. This must be on the interval AB. And if the function fx has x-intercept between a and b, so f of x has x-intercept on AB, right? Inside between A and B. Okay, how do I know whether f of x has x-intercept on the interval AB? So the method is called intermediate value theorem, right? So do you remember the intermediate value theorem? Intermediate value theorem says that if f of x has different sign at A and B, and if f of x is continuous on the interval AB, then there must be a point x equals to c in AV where f of x equals to 0. What does that mean? This means if a function is negative on A and positive on B, that's what it is, right? In that case, you see that there is a point somewhere between A and B where the function is 0, or the height of the function is 0, right? And that is very obvious. So another example can be, suppose you have like this, okay? At the point A, the function is positive, right? At the point B, the function is negative, right? So if in that case, at A it is negative, positive, at B it is negative, so there must be a root, or there must be an x-intercept between A and B, okay? That is always true. But sometimes though, there may be like this. You see that? At A, the function is positive. At B, the function is also positive, but there is a root, right? So that can happen. But what we can say is, if the function has different sign at A and B, there must be a root, or the 0 between A and B. But if they have the same sign, we cannot say whether there is a root or not between A and B. But if they have different sign, there is for sure at least one point. There must be at least, I should say, at least one point, right? Another example could be, let's look at this one, okay? So let's look at this. Let's look at this function. Suppose this is A and this is B. You see that? At A, the function is positive, right? At B, the function is negative, but there are how many roots? 1, 2, 3 x-intercept, right? So there must be at least one, but there can be more than one roots to, that's what the intermediate value theorem says. If f of x has different sign at A and B, then there must be at least one root, or 0, between A and B. That's what the intermediate value theorem says. Now, how does the Newton's method work? So this function is continuous and differentiable between A and B, right? And also it has a different sign at A and B. So we can apply the Newton's method. Now how do I do that is, I always pick select. I don't know how much is that. I select a value, some random value, let's say x1. I'm selecting x1 here. And then let's go to the function. So what is this point? This point is x1 comma fx1, right? This is x1 comma fx1. Meaning this is x comma y, but what is y? Y is you plug in x1 to the fx, right? So you'll get fx1. Now what we do next is you draw the tangent line. So the tangent line will be right here. So this is, let's denote this as x2. This point is x2. Now what you do? You go back down to the curve and then mark that point and draw a tangent line. Look at that. The tangent line is crossing the x-axis close to the solution, right? You see that? Whenever you draw the tangent line, it is crossing the x-axis close to the root that you are going to find out. Because our goal is to find out this point. We started some point x1. It could be somewhere, anywhere there, but you should take it close. Now go back to the curve and draw a line. Draw a tangent line there. So the tangent line will be very close, right? So basically the tangent line is crossing the real root that you wanted to find out. Okay. So how do I do that? What are the steps to use the Newton's method? Is, let's do the steps for the Newton's method. Okay. So the first, what we do is pick an initial guess x1. Number one is find the equation of tangent line at x1 fx1. Do you remember the equation of tangent line? How do we find out that? It is like y minus y1, right? What is y1 though? So y1 will be f of x1, right? Because it is like x1 y1 type, right? So x1 y1. So y1 will be fx1. So y minus fx1 equals to f prime of x1. That is the derivative, right? M. And then you do x minus x1. So after you do this, this is the equation of the tangent line, correct? So what we do next is basically we find out. Number 3 is find x-intercept of the tangent. So how do I find out the x-intercept of the tangent? What we do is we set y equals to 0, right? If you set y equals to 0, you will get 0 minus f of x1 equals to f prime of x1 times x minus x1. That's what you get, right? So let's go there. What do you get? Next is f of x1 divided by f prime of x1 equals to x minus x1, right? Now solve for x. So next what we do is we solve for x. So when you solve for x, what you do is you add x1 on both sides. So you get x equals to, this goes to the other side. So x1 minus f x1 over f prime of x1. This is what you get. This is the x-intercept, right? So what we did is we pick an initial guess. We went to the curve and then we draw a tangent line there, right? We draw a tangent line there. And then we draw the tangent line and find out the point where it crosses x-axis, right? That's the point where it crosses x-axis. And to find out that point where it crosses x-axis, we said find out the x-intercept of the tangent line, right? We said y equals to 0 and solve for x. That's the x-intercept. That is basically the x2. So denote this by x2. Denote it by x2, right? Now what we do is we have x2 equals to x1 minus f x1 over f prime of x1. This is what you get. So next what we do is on x2, go to the curve. What is the coordinate of this point? It will be basically x2 comma f x2, right? So this is that point, this point. So now you draw the tangent line. So what is the equation of the tangent line? It will be y minus fx2, right? Y minus fx2 equals to f prime of x2 times x minus x2, right? This is equation of that tangent line. You see that? Now, similar to the above, you find out the x-intercept of that. So find the x-intercept. Find the x-intercept. X-intercept. How do I do that? You do y equals to 0 again, right? Y equals to 0. So what you get is you will get 0 equals to fx2. Sorry, 0 minus fx2. So to find out the x-intercept, we plug in y equals to 0, right? So you get, you plug in y equals 0, 0 minus fx2 equals to f prime of x2 and then times x minus x2. You see that? This is 2. Okay. Now I want to solve for x because I'm trying to find out the x-intercept. So again, divide by f prime of x2. What do you get? You get negative fx2 over f prime of x2 equals to x minus x2. So if you add x2 on both sides, you will get basically x equals to x2 minus f x2 divided by f prime of x2. Look at this. What is the similarity between this and that? And denote this x, that x as x3. So we denote that x as x3. So basically x3 equals to x2 minus f of x2 over f prime of x2. You see that? So basically this is x3. And if you continue this, what do you get? You can tell me. So x, if you continue like many times, so in the nth step, what you get is x of n plus 1 equals to x of n, because see, whenever there is 3, there is 2, right? 1 less. That's why there is n plus 1, so there will be 1 less. So whenever there is 2, there is 2, 2. Whenever there is 1, there is 1, 1. So we will have f of x n divided by f prime of x n. This is called Newton methods or Newton formula, okay? This is called Newton's method. So basically we continue this until we reach to the desired accuracy. What does that mean? For example, when you find out say x1, x2, x3, x4, x5, x6 and so on, then you will reach to a point where x5 or x7 and x8 are very much equal, very much similar, or x9 and x10 are very equal, and then you stop.